In the previous video, we saw the relation between angular momentum and torque or moment of a force, right? Now, is it true for just one particle or for all the particles? So that's what we are going to do in this video. Okay, for system of particles, we try to find the relation. Okay, so let's start with the first case, which is we took the angular momentum, right? So here also the same thing. We have L is equal to L1 plus L2 plus L3 till Ln, meaning the angular momenta of each particle. Since we have n number of particles, this is what we have. Now we have L1 is equal to R1 cross P1, L2 is equal to R2 cross P2, right? So technically speaking, the L value, that is the net angular momentum, will be sum of all these cross products, correct? So we can write L is equal to sigma Ri cross Pi, I is equal to 1 to n, where it ranges from first particle to nth particle in the particular medium, right? Next, what we are doing, we have to differentiate this, that is the rate of change of angular momentum. So we get dl by dt is equal to sigma Ri cross dpi divided by dt plus dri by dt cross pi, where I ranges from 1 to n, same thing. Okay, just like what we did, dpi by dt is nothing but fi, that is the rate of change of momentum of all the particles, is nothing but the force, and similarly dri by dt is vi, correct? So the rate of change of the displacement is nothing but velocity, right? So if you substitute that, we get dl by dt is equal to sigma Ri cross Fi plus Vi cross Pi, right? Again, the momentum Pi is equal to m into Vi, right? So Vi cross Pi, it's nothing but 0, right? So we get dl by dt is equal to sigma Ri cross Fi, I ranges from 1 to n, right? So this is what we have. Again, what is Ri cross Fi? We have torque. Okay, but here one more very important concept comes. See, we are talking about force of the entire system, correct? So of all the particles. So we have two things here. One internal force, one is external force. Okay, here the sum of internal forces becomes 0. Okay, why it becomes 0 is by Newton's third law. See, you have two particles. One particle is giving the force in this way, so one more will give in this way, because Newton's third law of motion. Every action has equal and opposite reaction. So the net internal force of the whole system becomes 0. Okay, so once this becomes 0, then what do we have? Only the external force comes. So we have dl by dt is equal to sigma Ri cross Fi external, where I ranges from 1 to n. Okay, so Ri cross Fi external is nothing but torque which is happening in the external force, or which is due to the external force. So we get dl by dt is equal to tau external. Okay, so only the external torque is nothing but the rate of change of angular momentum. Okay, so this plays a very, very important part. Alright, so what we can say is the rate of change of angular momentum is equal to net external torque. Okay, net external torque. So this particular equation, what we just saw, it is analogous to Newton's second law of translational motion. This is what I was talking in the previous video, because the rate of change of linear momentum is force, correct? So here the rate of change of angular momentum is moment of a force, which is nothing but torque. Okay, so whatever the laws and whatever the formulas and whatever rules we have for translational motion, we apply the same thing even for rotational motion. Okay, so remember, we have dl by dt is equal to tau, or the rate of change of angular momentum is equal to the net external torque which is being applied on the body.